welcome to Simcast, a podcast brought to you by the Society for Imaging, Informatics, and Medicine. Greetings, Simcasters. In this exciting episode of Simcast, we'll be meeting with the members of the ACR Data Science Institute. Chris Treml is the director of the Data Science Institute at the American College of Radiology. Together with data scientists Laura Brink and Kendall Schmidt, the team will discuss with hosts Prasanth, Mohannad, and our newest member, Ali, about the amazing things going on at the ACR DSI, from federated learning to interpretive and non-interpretive AI models and applications, as well as an overview of the tools required to get started in the exciting world of machine learning and AI available. Links to these resources can be found in the show notes. A special thanks to Dr. Raim Geis for giving the team the idea for this episode. We hope you enjoy.
Welcome and thank you for joining us. Chris, Kendall, Laura, it's just such a pleasure to have you here. I think we are all excited to hear more about the ACR's Data Science Institute, so I think let's just get into it. Chris, can you start us off with telling us more about the Data Science Institute, what it is and why it exists?
Yeah, sure. The Data Science Institute at the ACR, we started a little over 4 years ago now. And really our main goal was, as data science is coming into the clinical practice, as it's changing patient care, how radiology is working, is to take and try and combine the leverage of the clinical knowledge that radiologists have that they're using day to day and bring that in, and having that combine with what's happening in data science. That way we can help essentially come up with a future where all this stuff's working together very well to increase patient care and have radiology kind of evolve into having it be another one of their essentially tools in their tool chest along the way. And that's kind of the shortest answer I can come up with. I can give you a lot more than that, but that's really what our goal is, to help advance the radiology profession, to help incorporate how this needs to play into patient care.
Thank you, Chris. So with that being said, I'm curious to know a little bit more about Informatics E-Learning Hub. Do you mind outlining that for our listeners?
Yeah, I'd be happy to. So our e-learning hub, we launched several months ago now, and that came off of, there's a lot of these overall topics that we kept coming up where either we do webinars, we go to conferences, do one-on-one conversations around that kind of stuff. What do folks need to know what's happening right now with data science and in clinical practice in different ways? And so what we started to do was just start and collect that into just this e-learning hub of, here are very approachable videos for folks to understand those different topics. So it's not for CME, it's not here's a whole lesson plan of formality, but things that we're coming up a lot. Like, for instance, a really good one that we had on recently was government regulation and AI. It's an area that we almost give the same talk about all the time of, here's what the FDA is doing, here's what we're seeing across the board, here's things under discussion, in ways where folks can just kind of understand what's happening today, what makes this area unique, and kind of what's the thought process of how things might change in the future. What's the goal of, just so someone can pop in, understand the high level of that concept, and not have to enroll in a whole course or stuff like that.
So you mentioned that at a high level, the information is there. How much can people drill down to? How granular can you get? Can you get all the way down to like different bills, like you were talking about FDA governance and whatnot? Can you get down to different acts or bills or things like that? Or do you just reference off to other things?
For a lot of what we have in the e-learning hub, the goal is to keep it at a high level and reference off to other aspects. Because a lot of what we were seeing, the hard part for folks to be is, like, if you were already, I'll pick on government regulation again. If you're already really big into that area, you know a lot of what's going on, you have all the resources. It was hard for folks who were trying to just figure out, I heard about it, but I don't know what's happening. I don't have years of experience and a whole network that I can just rely upon. So we're really trying to aim at those folks. Those folks who are trying to go, from 0 to 1 or 1 to 2 and from there. And then there's tons and tons of other resources along the way that we can help put you down to, including some of them as well are stuff that we reference of just what we're doing as well. So for instance, our data sharing video on that, we reference a lot of the other materials we produced in the last several years on data sharing, like the ethics of AI and data sharing and so on. So really, but that's our goal, is to have that be a high-level starter point for lots of folks.
And so in line with that, but going forward with, in your experiences so far, what's like seeing data scientists come into imaging informatics? And I don't know, Kendall and Laura, if you have any thoughts on that. But I think we're seeing more and more of this, and it'd be great to see what it's like on your end of things.
Yeah, sure. As a data scientist myself coming into imaging informatics, I didn't have any medical background before. I was very used to having sort of neat and tidy data. And then, of course, you come into the medical field and it is definitely not neat and tidy. And I think what's really cool about this is that it's very key to have the collaborations. So even though I have the expertise in maybe statistics and the machine learning, I definitely don't have it when it comes to the applied use cases for the imaging. And so it's really important to sort of build those connections across all of the different fields that there are and get everybody involved in the actual data processing and even the testing and everything.
Kendall, would love your thoughts too, if you'd like.
Yeah, sure. My background is also not in radiology. I'm coming from a signal processing background. And so getting started as a data scientist in radiology is definitely challenging. As Laura mentioned, you really do need to involve a lot of different aspects of the field in order to have a grasp, in order to understand, what is useful in terms of data science development, the best way to tackle problems. And so it really is just a huge group effort.
Laura and Kendall, you both mentioned some of the challenges coming in from other fields into imaging informatics / radiology. What are some areas, other than what you've already mentioned, that the Data Science Institute here can help smooth out? How can they help reduce the barrier to entry, as they say in other fields, for people so we can attract more data scientists into radiology and imaging informatics and make it easier for them and subsequently easier for us to move forward with many of these projects?
So I'd say that one of the main things that the DSI is doing is developing these AI use cases. And the use cases are basically the radiologists and allied professionals' way of telling the data scientists or the developers, these are the problems that we're having in our field, and we think it would be awesome if you guys could try and help us solve these. So the use cases basically spell out, here's our problem, here are the inputs and outputs that we would want from an algorithm. If you guys want to go tackle this, this is where you should go, and this is how it's going to be useful for us. So that's something that people can go to right now and see, and you can even browse through them and see if there's anything that sort of catches your eye. But I think in general, to attract more data scientists into this community, one of the cool things I think is basically getting involved in the cutting edge research within AI. So looking at things like the explainability of AI and how that affects the medical domain, generalizability like federated learning, which I think we'll probably talk about. Those are really hot topics right now. And I think that the more that we pursue them, the more that we can get the larger AI community involved.
Kendall and Chris, did you have anything to add on that? Would love to hear your perspective as well.
Yeah, I would say too that all of the education effort that the DSI is putting forth in order to educate radiologists on AI is really helpful, because I think that if AI is not necessarily in a radiologist's background, they may not understand how AI can help them. And so having that educational foundation helps radiologists to decipher problems in a way that we can help out with.
Yeah, one thing I was going to mention too on there, because it's a little more behind the scenes, but we've done a lot of work on this, is in addition to the use cases and kind of bringing radiologists up to speed and going from there, is we also have been devoting a significant amount of energy towards standards in this area. So we've been working with DICOM, IHE, HL7, FIRE, so on, about, okay, so if you made a model, that's all well and good, but then you have this problem if you have to somehow deploy into this heterogeneous environment that has dozens of different PACS vendors out there, 2 major reporting vendors, but if you get to the sub areas, you get to about 10 or 12 of those. And so you get this problem of data scientists where they want to focus on getting their models up and running and how do they communicate it out. And what they end up doing is going into almost like an integration engineering problem. And so we've done a lot of work. For instance, we were one of the main people help pushing DICOM Supplement 224 to say how you can actually integrate this in. I wish I could remember off the top of my head what it was, but we just also had an IG profile about how to do all this work as well that we helped get released as well this last year. And we've been talking with some future stuff too with FIRE and other folks on how to do this well, but just how to lay down some of those railroad pieces so all those last mile problems don't become such a barrier to folks as well. It's another area we're pushing on. It's a little more behind the scenes.
So I'd like to maybe take a quick detour and come back and talk a bit more about AI. So I've seen on your website that the Data Science Institute has got services like Connect, AI-LAB, AI monitoring, validation. Can you tell us how these services work and what kind of problems you're aiming to solve with these?
Sure. I'll probably take them in the opposite order that you listed them out because I think it actually rolls them best that way. But so with validation work, we have a service called Certify AI, and that's built upon, so the college has 15, 20 years worth of experience doing multi-site clinical validation. Actually, our research folks are going to tell me I'm wrong. They're probably saying it's closer to 30 or something. But we have a lot of experience acting as a research organization doing multi-site validation. We started that up because what we were getting a lot of feedback when we were first starting is just how much of what I'm about to describe happens so often where an AI developer gets access to data set from, say, maybe one institution or maybe one or two organizations in one geographical area. And they essentially overfit their model to that data set. And then when they try to bring it to the general population, so let's say they bring it to another organization that's across the country or different patient demographics, it just doesn't work well at all around it. And the problem is that they don't really have a good way of solving that unless you're a huge, multi-billion-dollar organization that's already inside this area. And even inside of those, how do you play out with it? So we started with validation because we already have the infrastructure, the background, how to guide through it, that we can help provide those things to say, hey, if you have a model that you think actually can detect pneumothorax with 99.99% accuracy around it, we can get 20, 25, 30 different organizations involved, all commit a profile data set based on the clinical problem of what you're trying to solve and actually test it against there and give you feedback on, hey, is this actually good enough to really general population? Or maybe what you're seeing works really, really well, except for when you hit a Siemens scanner. And that's when all of a sudden your model starts going really down and what's happening. And we can help explain that out to you and why. Monitoring goes a bit the opposite way too, because the hard part we had is I could reference a couple of different papers that happened, but for brevity, I won't on this one. But there's a lot of scenarios where people are seeing AI and what they're treating it as is other software models they've done, right? So they go through a selection period, they go through a testing period, and they go through kind of a period, right, where they're monitoring it closely because they're unfamiliar with it. And then 3, 4, 5 months out, they just start trusting it. Everything's good. But the problem we're seeing with this is you tend to get drift off of it, right? So your patient demographics change, the protocols on your scanners change, you buy new scanners, the way you do scanning changes over time. And as that drift starts to occur, what is really insidious in all of this is oftentimes, unless it's a really massive error, you don't kind of notice it. If it's a small one that's 10% off, 15% off, 20% off, it just slips into the background. And then a major error occurs and you realize it's actually been having problems for the last year. So our monitoring program is based upon our registries we've done. So folks might know it as near, but we have things like Dose Index Registry, NND, Grid, where we already have infrastructure in place in sites across the country enrolled, where they feed data to us in different aspects of what's going on. So we can give not necessarily real-time monitoring, but we can give you close to real-time monitoring and also help you do benchmarks. So how do you compare to your other sites? How do you compare to the national average? How do you compare towards other folks in your state or types of organizations like yours? That way people can start seeing issues up front. A really good example of this as we've been rolling this out, there was one organization, they rolled this out and within about a month, they realized that there was one scanner they had that every time a study came to that scanner, it was getting very, very poor results. And the problem with that was that scanner, I think, was doing 5 millimeters and the rest of them were all doing 2.5 millimeters, I think is what it was in the end. And they were able to find that very, very quickly because we were able to feed that data and just show them how the trends were forming out.
AI-LAB is a data science toolkit with the goal of democratizing AI. And what I mean by that is we're trying to empower our non-technical users to get involved in the AI testing and training. So it's primarily geared towards radiologists right now. And so a data scientist like me might find it actually a little bit frustrating because the options are limited. But for radiologists, it's really empowering because they don't need to know everything going on behind the scenes to actually use and train AI algorithms. So within AI-LAB, you can annotate images according to an AI use case. You can go to the create page and you can choose these hyperparameters. The goal is that you can't break it. So you can sort of play around and get a feel for okay, what happens if I do equal sampling of my data or if I just do the random sampling. And so it can be very helpful in terms of education as well. And so then once you've trained an algorithm, you can also go to our evaluate page and do testing. So you'll see the confusion matrix if you're doing a classification algorithm. You'll see a mean squared error if you're doing some sort of regression. And so we're giving the radiologists the information and tools to start learning sort of the language around, okay, how do I evaluate the metrics that I'm seeing around these algorithms? And how do I know if it's actually good or not? And so another important portion of AI-LAB that we're currently working on will be sort of the monitoring of the biases that some of these algorithms have. So we want to give users the tools to break their data sets down into subgroups by demographics. So you can see, oh, okay, how does this algorithm perform on my patients who are 65 and older? How does it perform on the 65 and older who are African American? So we think that this will be really important along the lines of the AI monitoring and validation as well. Let's see, is there anything else to add about AI-LAB?
I don't think so. I think that's what I'll probably add on is actually what goes into the Connect aspect. What Connect does on top of AI-LAB is, in addition to this data science environment, there's lots of things that the college does that interacts with local sites in their data. So like I said, the research trials we have, registers we have, and we've been working on for a while how to improve what's our next iteration or next step we want to do for the software we deploy at those sites to help them participate. That's one of the big areas we've gotten a lot of participation in. And so that's where Connect really came from. So we said is instead of having a bunch of little software things that people install to say participate in DOS, participate in research trials or this, let's combine it down into a suite off of there. So Connect is that suite. It's the platform that you would install. And once you do that, you have access to different workflows on top. One of them being AI-LAB. What that allows us to do is to say, once you've set it up once and you've connected to the ACR, there's a bunch of different stuff you can do as well off it. And then lets us integrate and have all the benefits you get off of that as well. And so what that would mean then for folks, I think on this call, be really interested is that as we roll this out, is that if you have Connect, that means you would have AI-LAB. Or if you're looking at AI-LAB, what that means is you install Connect and then you get a bunch of other stuff along with it. For instance, just as a side on what that lets us do is things like, so one of the things Kendall's working on right now is an algorithm that we can use to help automatically map local procedure names to a normalized one we have called ACR Common that also maps to RADLEX and others. Because that's always one of the biggest pains people have, just how do you do that mapping so you can normalize across those benchmarks. So she's working on how we can do that. And then we'd be able to deploy that onto the Connect platform, which means it would work for AI-LAB and it would work for everything else we do, like accreditation, registries, and so on.
I think this is fantastic. And there's so much to talk about here, but I would like to pull the conversation back just a little bit to talk more about those use cases. So I know we've seen an expansion in the use cases and recently seen the addition of non-interpretive use cases. Is there any plan on expanding these? And if so, how? Are there any other priorities for the use cases from the DSI's perspective?
A couple of, one is we started the non-interpretive use cases a little bit later than the others. And I think it's just the nature of our organization where a membership association or a professional society of radiologists, they understand the clinical side a heck of a lot better because that's what they do day in, day out around it. We started that up earlier this year, late last year. So we kind of have two goals, I would argue, over the next year, or two major avenues we want to pursue. One is building up a lot more of the non-interpretive aspects. That one gets a bit more challenging because a lot of times non-interpretive aspects, you don't have as much of a clean, here's the image, I want this diagnostic and go after it. It's usually a lot of workflow-oriented stuff that depends upon how you do things at your site, your systems. They get a little more complex. So one is we always appreciate any kind of feedback we can get from outside sources or other folks who just want to collaborate with us on it. Our non-interpretive panels have been very open to that. The other one that we're looking at focusing on too is, so we have our FDA cleared list of algorithms that we've been improving and looking out as well. And we have those mapped to the use cases as well. We want to do two things. For one is go through all the ones that don't have the use cases associated with them and see what it would look like to build a use case around. Because we knew when we did a lot of this stuff, like industry's moving at the same pace, we can't expect everyone to slow down for us. So we wanted to kind of analyze those and see, are people making things that our members, our radiologists are finding useful? And if so, we should get those added in. Are folks making algorithms that our folks are thinking are not useful at all and they want to go after? And that's its own kind of insights that plays out. But that's another area that we want to focus on with those.
Excellent. And thank you for that. And so, with all these tools that we've discussed, are we monitoring how extensively they're being used or who's using them? Do you have more information on that? And then also, and kind of part two would be if there's any cost that be associated with these for the long term or short term.
Gotcha. We are monitoring it. One of the hard parts that we have with it, so to speak, is I'll pick on the use cases. Part of it when we did the use case, and we knew this would be a weakness by design, is that we wanted to be freely available for everyone to use. That's why we released them under Creative Commons. We want people to reference and build upon them, use however they need to use it. What that inherently means is you can't necessarily track who's using when and how and why, but that's okay out there. So one thing we have been tracking is just how many people are looking at these things. Of the models that have been released, how many actually correspond to our use cases or relate to them in some way, shape, or form around it. And it's been pretty good. We've been seeing pretty consistent numbers as the library's been growing of where they're looking at. We've been seeing trends in terms of which use cases are most popular when. And it's interesting, you kind of see this trend or suspicion. I think it's still too early to say it's a trend. But you'll start seeing things like one use case will start having lots of views and we'll get lots of feedback off of it. And then maybe about a year later, you'll start seeing a couple of vendor algorithms that correspond to it as well. So it's hard to really say a trend because you need at least, I would argue, 3 or 4 times that happens. And we're kind of running up on the 3rd or 4th time now. The other thing too, off the services we mentioned, like the AI monitoring validation, those are services that definitely have a monetary aspect to them. So for instance, validation is an easy one that it's very much like a subset of our multi-center clinical trials. We do contracting with folks, especially if it's a vendor solution. We basically tell them what the cost will be to be able to do validation of the algorithm. We enlist sites, the money passes through us at the sites as they're actually collecting the data and doing stuff like that. AI monitoring, we're still working out the long-term monetization of that one, what it's going to look like. It's almost guaranteed it will. It'll probably follow very similar how the rest of our registries work. At the moment, we're still keeping that in a pilot stage because we're working out what are the elements that need to be collected? How exactly does this play back? Who has access to it? How that needs to happen? So until we sort a lot of those things out, it'll be in a free state as folks are participating, helping us work that out. The other aspects like Connect and AI-LAB, those are free, and we want those to be free. If you're thinking about from how do we make it sustainable, that's actually part of the reason why we wanted to make Connect as this integrated suite of platforms, because what we do at the ACR is we don't sell software, but we do charge for services. And Connect allows more and more folks to have access to our services along the way. So that's kind of how we have a sustainability model there. But from a software standpoint, we give away all our software for free. I'm trying to think if there's any exceptions to that case, and I can't think of any off the top of my head. There might be a rare one, but that's really what we do. We try to get people involved in our services.
Awesome. So we're going to switch gears a little bit. First, Kendall, thank you for working on this problem of ingesting new data and mapping into the current location. We literally were talking about this at our hospital informatics meeting yesterday, since we're a tertiary care center and we're getting patient data from all sorts of different sites. How do we map this correctly? So I am super psyched that smart people are working on this problem.
You know, that problem is a really good example of how much of a group effort some of this AI development is. I personally cannot look at a study description and map it to anything. I don't know what they mean. So it's a really good example of how all of the different departments within ACR involve the clinical imaging department, the quality and safety department, as well as external radiologists in order to create a well-annotated data set to use to create these types of models.
Yeah, and it's not like there's a wrong way. You know, you can say CT head CT, things like that. Everyone's just got their way of doing it, but yeah, having clean data makes a huge difference. And I was wondering, it looks like the federated learning will be available for the AI-LAB, for users to participate. Can you describe what this is about? What's it like, and what value or what experience can the users expect?
Yeah, sure. So I'll just start by explaining federated learning. I'll put it into perspective by first talking about how you train a AI model traditionally. So traditionally, when you go to train an AI model, all of the training data is in one location. It's all on a single server. But to train an AI model that has robust performance across multiple different locations, multiple different applications, the training data needs to come from a selection of diverse sources. And you can imagine this is pretty challenging when it comes to medical imaging data. It's hard to get a lot of medical imaging data from a lot of different sources just because of how sensitive medical imaging data is, or medical data is in general. So federated learning is a way of creating ML models or AI models with training contributions from a lot of different sites without having to move the training data to a central location. And the way this works is that a central server passes a starting model to all participating sites. And then each site will train the starting model on their local data. And once they're done training, they'll pass the local models back to the server. And when the server has collected a local model from each participating site, it will then aggregate those models together to form one aggregate model. And so aggregation can be as simple as just taking all of the models and finding the average. But the point is that multiple local models are condensed down into one aggregate model. And that aggregate model can then be used as the starting model for the next round of training. And so if this process of passing a model to participating sites, having the sites train that model, passing the trained model back to the server, aggregating that model, if that's all repeated over and over again, the final resulting model, it's been shown that the performance reaches a similar level than if all the training data had been moved to one central location first. And so it's a really powerful way of creating robust AI algorithms without having to move data around. And I guess I'll also add that federated learning through AI-LAB will be very true to the nature of AI-LAB. So it'll be geared towards non-technical users. And so it'll all be through a graphical interface. It'll all be press this button to join. And so no technical expertise will be needed in order to participate. And I'll also say that we are currently looking for participants for our inaugural AI-LAB federated learning experiment. So anyone who's listening and who's interested is encouraged to go to the AI-LAB homepage, which is ailab.acr.org, and click Learn More under the federated learning section on that page to indicate your interest.
That's awesome. So I've been reading a little bit about homomorphic encryption, which allows for data to be used still encrypted by another site and still be able to get the same results. Is there anything that you know of that would describe one that works better than, does using that process work better than federated learning or vice versa? Or do you know much about it? Because I'm still kind of dipping my toes in the water a little bit here. And I know it's not a fully, fleshed out field, shall we say, yet.
Yeah. So homomorphic encryption refers to the communications between the server and the clients being encrypted. And we're actually using an NVIDIA software product called NVIDIA Flare that offers homomorphic encryption as an option. So we can encrypt the communications using HE.
This is great. Thank you. You mentioned public participation, and that's great for federated learning, but I'm also curious to hear about the hackathon that the DSI hosted in 2020. And fun fact for our listeners, this SIM and ACR actually collaborated for that hackathon. So I'd love to hear how that went. If there are any lessons learned from that hackathon that you're able to share today, that'd be great.
Overall, I'd say I think it went really, really well. We definitely had a lot of good participation off of it. I think we also got a lot of really good feedback from it too. So one of the things we did with that is we were able to work out, it was a nice testing ground for AI-LAB to be able to say, how can we bring more and more models in under standardized aspects? But B, there was another part behind the hood as well that this helped us out, is we were currently working on DICOM Supplement 224, and it actually gives a lot of really good feedback that we incorporate in and of how things actually played out as people were trying to use essentially what was early DICOM 224 off of it as well. So we were able to bring that up with it. One of the, I don't know if it's lessons learned, we actually got, A, we got a lot of support from SIM, and that was really, really nice. And then B, our director of interoperability and standards, Brian Valaki, he has a lot of background in standards and this kind of work as well. And so I think because of the expertise we got from Brian and from the SIM folks supporting us, there was a lot of prep work that went into it to make sure it was as successful as it was. A lot of just reaching out to folks ahead of time, explicitly getting different folks involved, saying what the end goals were, both in terms of what the hackathon was and how we wanted to use information from the hackathon afterwards. And so I think it went really smooth and we got a lot of what we want out of it. And I can't speak for Sim, but I think you guys got the same feeling off it as well.
So, Laura, the ACR DSI and the American Academy of Ophthalmology recently announced a collaboration. How will this impact the current AI lab and where it goes in the future? Are there any plans for connecting with some of the other ologies, dermatology, gastroenterology, et cetera, because especially pathology is the big 800-pound gorilla. Everyone's waiting to come into this sphere. What are some of the roadmap for the collaborations?
Yeah, so we were able to add 2 ophthalmology use cases to AI-LAB. So as Kendall mentioned earlier, you can go to AI-LAB.acr.org and you can actually play around with some sample algorithms we have. So I worked with some researchers and ophthalmologists from the AAO, and we developed a diabetic retinopathy algorithm for the color fundus photos and a macular disease detection on OCT. And so this first collaboration was really about getting the education portion of AI-LAB. So users can go there and play around, click, train an algorithm, see how it performs, learn a little bit more about what the hyperparameters are and whatnot. In terms of moving forward with that, I would love to see us incorporate the ophthalmology use cases onto our Connect platform as well, because that would allow our hospitals to use their own data to actually try out these specific algorithms instead of just using the sample data. And as we know with radiology, it affects, all sorts of domains, all areas of the hospital. And so involving other ologies would be excellent. I think, Chris, you could maybe speak more about any plans for the future.
I think maybe for plans for the future, one of the things that the DSI has talked with, especially with ACR leadership a lot, is that, so part of our goal, I'll just go back towards, is really having radiology be at the forefront of data science and healthcare. And so we said, as this stuff's progressing, we really want to be seen as a leader amongst these different areas. And part of that means on our end is really we want to collaborate with the other specialties as much as we can, because as we're doing this kind of work, it's technologically, it's 80% the same, maybe 90% the same. And it's the clinical difference that's going to play it out. And so what's nice about this, we've talked with some of the pathology groups from the past and dermatology and others about what we can do. So to work with them, so they're not repeating the same thing, where we're all working together off of it. And ophthalmology was it was a really nice, I think, first foray to a true concrete collaborative project off of it. That from my hope would be is it opens up a lot more doors for the folks to be able to repeat it with others as well. We definitely are interested and want to do it. And then even like from the ophthalmology side, as we were talking with them, okay, we did this initial foray that was mostly focused on education. Once we really got that outdoor, it was interesting where like immediately the conversation went towards, maybe we should be trying to do a Federated Learning project with them and have them leverage the work we're doing with Federated Learning already. Or maybe we could work with them on distributed validation off of the same thing. It was a really interesting aspect of once you do that, you start walking down that pathway together. And I think that's one of the core areas of how we're going to actually have AI and data science really help patient care, is if you start getting some unification between these different specialties that have much more standardized pathways. And that's really something we want to be able to go after and do.
Excellent. Thank you for all that information. There is one thing that's slightly related that I wanted to inquire about. I'm a fan of the project, and I wanted maybe if you could introduce it to our listeners. So the ACR unveiled the FDA-cleared algorithms registry, I feel like it was about a year ago, and a data set directory. Can any of you tell us a little bit more about it? Why? What was it like creating these kind of resources? I'm sure it was a chunk of work. So yeah, please tell us about it.
Yeah, I can hop into that one. It actually was 2 years ago. We actually released it at the last time RSNA was in person, right before then. It wasn't quite nearly as spiffy off of it. And it's kind of funny, the original reason why we did it. We were collecting all this information internally, and we're like, man, when like our chief data science officer, Keith Driver, and he goes out to go talk to someone in a conference or something like that, he just doesn't have it on hand. Let's just post it online, make it easier for at least us to get access to it, and then everyone else does as well. And then same with the data sets. The same thing was like, what are the data sets out there? What are effective? What could they be used for? It's just same thing. We just felt like we're kind of collecting this data internally. Let's just spruce it up a little bit and put it externally and see what the reaction was. And especially the cleared algorithm one, it was actually, I want to say shocking, that's a little too much, but like the response was extremely positive, extremely fast off of it. We started to get from vendors who we had missed from various ways, just emailing us, telling us, hey, we want to make sure our product's on there, or if we had incorrect information, help correcting us. We were getting inquiries from some of our members who were asking if different data elements could be put on there that they're hoping to see and go from there. And so I don't know if for folks who might have remembered it, but our very first one that we did was just a static web page of straight text, here's what we found. And that was okay when there was about 17 or 20. The latest count that I saw, this was last week, it might have actually changed already, was 147 is our total clear that's on there. And so we started to very quickly pivot towards we need this to be far more interactive, not just a static web page. And that's what we've been working on for about the last year. So we actually launched it this October, a redesign of the site to make it much easier to slice and dice the data and get to what you want to get to. So for instance, let's say you as a user going in there and you only care about abdominal imaging. You can just quickly filter down to abdominal imaging. And if you want to go further, say, I want abdominal imaging and I want to know what's available that's on CTs. You can just quickly slice and dice and see that here are the 5 that are currently available for it, or what's new in the last year and so on. That one has actually been really, really helpful for us too, to do a couple of things. One is it's helpful for us in terms of where are we seeing the most growth happen? Interestingly enough, it's mostly in breast imaging and neuro. Those are by far the vast majority of where it is. Everything else is a little more scattered. And it's helped us see the acceleration. So like we've been putting together kind of this graph. So some of the stuff we want to also expand and release online because a lot of it's public information. But I think it also proves the acceleration of growth. So we've been seeing each year, not just the amount of algorithms increasing, but the rate that the new ones are coming out is going faster and faster as well as it plays out with it. And then there's also just a lot of stuff that we've been getting from feedback we want to be able to do with it. So for instance, right now, the way that we manage this is twofold. One is we have a staff member who monitors every month. The FDA releases, here's the new clearance on products. And they sort through that to what happens in imaging and what's inside of imaging, what looks like it's particularly AI based, and they kind of sort through there. And then once we identify that, we go through the 510K and we try to clear it out to the elements we have on the website. So like, did they list what validation data set they use? Did they list if they use a clinical study or not? Can we try to extract out what it truly is doing? Is it a triage or is it a quantification? Is it a certain type of finding or so on? So we try to do that all front as best we can. We also have our editorial staff that is available as well, that oftentimes our analysts will ping if there's a question. Because there are sometimes where it's like, unless you really know the clinical area, it gets a little confusing, try to pull it out. And then, of course, on top too, we'll get responses from vendors who will tell us that, hey, they think we interpreted it incorrectly, and we'll review what their request was and try to update it. But it's also been really valuable for us too, as we've been hitting down there. I think it's been helping not to realize, but help us get data to help talk to, say, the FDA and others of how little information there truly is out there on this kind of stuff. So I'll segue this a little bit into one of our other major aspects, but I think it's because this is where we wanted to be. But we've been putting together packs and talking to the FDA about having essentially like truth in labeling or transparency in labeling aspect we could get from this to say, if you clear it, we want to know things like how many studies or cases or patient was it used for validation? Is it from one state, multi-state? What were the breakdowns of those different aspects behind it? Just a lot of stuff like that we can do to really help pinpoint how things came out. Did you do an internal study with, just your own access, or was it an independent party who evaluated, so on and so forth? And we want to start pulling that stuff together because that's a lot of what we've been getting requests from members on is, they want to be able to know more and more, because what will happen is that their organization, they hear that, their organization's in talks with a particular vendor. So then they'll go to our site, they'll look up what they can off of it, but it's still relatively limited for them to be able to start having that conversation and getting a part of it. So they know, hey, we do a fair amount of pediatric cases at our organization, and I have no idea if this algorithm is trained or able to handle pediatrics at all. And so that's kind of stuff we want to be able to post on. That way people can say, hey, you don't. Not that you have to say don't use them, but during the evaluation period, you need to explicitly pull in pediatric cases to verify how they're going to work. Or if they make the claim from it, then you might know, hey, this actually might be a better fit for your organization. It plays out. But that's definitely one of the areas we see as a lot of future expansion on there as well. Just to help get as much information so our members are as well informed as they possibly can of the marketplace.
Truly, I think this has been eye-opening. And the more I hear about it, the more I want to get involved too. And I imagine that our listeners have the same question. So do you have any advice on how data scientists, clinicians, trainees, anybody, how can they get more involved with ACR DSI's current initiatives?
I would say that the first place for people to go would be the AI-LAB homepage, ailab.acr.org. It's a great place for people who are not familiar with AI at all. There's helpful videos to get your feet wet with just basic topics and conversations with clinicians about how AI might impact their workflow in the future. There's also demos to try out. And then, as Kendall mentioned earlier, if you're at a facility and you'd be interested in installing Connect in AI-LAB, or if you want to participate in the Federated Learning experiment, you can fill out a little sign-up form to say that you're interested. And we could get you guys started within a couple months using your own data to try out algorithms. And then for data scientists, if you have algorithms or data sets or projects that you want to work on and you want to work on them with us, we can help leverage sort of all of our tools that we've discussed today to get those algorithms tested and distributed to all of the sites that we have. There's also the DSI use cases. So for clinicians who want to contribute to the DSI use case definitions, you can comment on ones that are already published. You can also submit new use cases. So if there's a problem that you think an algorithm could particularly help you with in your workflow, then I would recommend you submitting a use case for that.
Thank you, Laura. And Kendall, Chris, anything else to add on in our final moments here?
I do have one thing to add before we stop recording on homomorphic encryption. I don't think I made the distinction very well. So you asked specifically about encrypting homomorphic encryption for data transfer. And I just want to make it clear that with federated learning, you're not transferring data anywhere. So there's no need to encrypt data. What does get encrypted if you use homomorphic encryption while performing federated learning is the model weights. HE is not restricted to encrypting data. It encrypts whatever you're communicating between the clients and the server.
I was just going to add on too, is one of the things that we hit on, I'm sure you guys are seeing the same thing too, this area. This area is so wide open and continues to grow so much that our general approach for a lot of stuff is we're always open to talk to anyone out there. And really, as collaborations of opportunity come up, we'd love to do them. What I mean by that is, for instance, we'll talk with a lot of vendors or say organizations, individuals who there's a lot of overlap in interest that we want to pursue the same things. But it may not just work for my priorities at this moment in time to work on a project together. That's completely fine. And then what ends up being is maybe 6 months from now, your priorities will be opened up, they overlap together, and we work on together, because our goal in this area is not to try to be like, we're the ones who are going to take on everything. We're going to set the standard. It's all ours. We're going to have them from it. Our entire goal is just, we want to have a very robust environment that's making patient care better. That's really what our end state is behind it. And we can do that by just helping out as many different areas as we can and helping support others along the way. It's kind of like a non-answer to how do folks get involved and come from it. Because a lot of it is what we see is where folks are already involved in different areas. It's when there's a good chance for opportunity for support, for overlap, for working together, we're very much in support of that and love to do that kind of work.
That's absolutely perfect, because it gives us kind of a common goal at the end of the day, which is to help patients, right? And it's to come together, multidisciplinary means working together for that goal. So thank you again. I'd just like to thank all of our guests, Chris, Kendall, Laura. You've been absolutely fantastic. This has been a stimulating talk. Mohannad and Prasanth, again, it's been a pleasure having y'all here as well. And I think with that, we'll see y'all next time.
Simcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.